Hello, welcome to MV Tutors. My name is Figa and I am your tutor today. If you would like a session after this, now that's a tutorial session, visit our website www.mvtutors.co.za or alternatively comment under this video asking for one and we will be glad to assist you. But nonetheless, today we are talking about trigonometry, 2D and 3D. Those are dimensions. Now, I like to start my sessions with a vision. And the vision is just a past exam paper or question. All right, so now we have this question right here. If you look at this question and you think, maybe I might not be able to answer this particular one, then stick around. By the end of this session, I'm sure you will be. We will do this question here. But first of all, we need to learn all the principles that are required of you to learn in solving these kinds of problems. So now this is really a topic of triangles, but before we talk about triangle, let's talk about the angles in a triangle. One thing that you must know, especially when they ask questions, is the difference between an angle of elevation and depression. So this is an angle of elevation because it's going up from red to blue. This is an angle of elevation. Okay. But if it's going down like that, then this is called an angle of depression. That's it. Now let's talk about right-angled triangles. Okay, so this is a right-angled triangle right here. And what makes it a right-angled triangle is that right angle there. It's perpendicular. Now, let's say this angle, this is the angle of interest. We'll call it theta. Okay. And then this is going to be A, that's going to be B, and that's going to be C. Those are the sides there. Now, we know that by definition, if you know this, saw, car, Toa. Okay, so what is SOHCAHTOA? That sine, okay, is opposite over hypotenuse, and then that's cos is adjacent over hypotenuse, and then that's tan is equals to opposite over adjacent. Now, these are the opposites of the angle itself and the adjacent of the angle itself. So when it comes to sine, then sine theta of this particular red triangle, we know that it's opposite over hypotenuse. Okay, so which in this case is the opposite of theta is A divided by hypotenuse is C, right? Okay, now if we move on and say then let's do the cos. Cos is equals cos theta rather is equals to adjacent over hypotenuse. These are basics, right? You probably know them, but I just wanted to put them on the record. Now, adjacent of theta is B over hypotenuse, which is C. And then let's do 10. 10 then, 10 theta will then be equals to opposite over adjacent. Okay, and the opposite is A over B. That's if you have a right angled triangle. You can solve any side and any angle using this. Alternatively, you can also use, if you want to solve any side, you can use Pythagoras, which says c squared is equals to a squared plus b squared. That's Pythagoras. You can use that to solve any side. Pay attention, only if you have a right angled triangle can you use these. Any other condition, if this is not a right angled triangle, then you cannot use Pythagoras. All right. Now let's say you have a triangle that is not a right angle. Say you have an arbitrary triangle just like that. Okay? That's gonna be angle A, that's gonna be B, that's gonna be C. They are in capital letters. Now, opposite angle A, we have side A, small letters. Opposite angle B, we have side B. Opposite angle C, we have side C. That's how we name it. And then, how you would solve this, you can use, Socator or Pythagoras to solve the sides. So we use what we call the sine rule. Okay, just like this, sine rule. Okay, and then the sine rule says A over sine big letter angle A is equals to B over sine B is equals to C over sine C. Then you can solve, or depending on what you're solving for, you can also have it as sine A over side A. You see what's going on here? Sine B over B is equals to sine C over C. Now that's what we call the sine rule. But hold on, that's not all. We also have what we call the cos rule. Now let me just redraw the triangle again. We have A opposite. We have B opposite. C opposite. Now we have those. Now the cos rule or the cosine rule says, well, a squared is equals to side b squared plus c squared minus, okay, minus 2bc, okay, and then the cos of angle A. Okay, so that's if it's A. If you want to solve for B, then b squared would then be equals to a squared plus c squared, okay, minus 2ac cos of B. I'm sure you're starting to see the pattern now, that you actually start with the side that you're looking for, and that's going to be equals to the other sides. So the other sides of C is A and B, and they should be squared, and then you subtract the same other sides but with the 2 there. So it's AB, and then when you write the cos, you write the cos angle opposite that side, which is C. That's it. Okay, now we have all the principles that we need in order to answer this question. But let's go ahead and read it. From point A, where's A? There it is. An observer spots two boats, B and C, at anchor. Where's B and C? There's B. There's C over there. Got it. The angle of depression, there's the angle of depression we're talking about. Remember depression, we said it's an angle moving down from a horizontal. Boat B from A is theta. So there's the theta, the angle of depression C, it's going down. D is a point directly below A. So where's D? There it is, it's directly below. And is on the same horizontal plane as B and C. Okay, as B and C, I can see D, all right. BD is 64 as shown. Okay, I see. AB is 81. Okay, as shown there. AC is 87 as shown. So this thing really looks like, if you can imagine a corner of a building inside. Okay, so I'm sitting inside a room and there's a corner, well, right next to me, but you can't see it. But a corner at the bottom, because the shaded area is the floor, and then D is the corner, and then moving up, that will, A would be on the roof, or ceiling rather, the ceiling, and then these sides are just the sides of the corner wall. All right, so just imagine that, but you can see it as well if you can't visualize this properly. Now it says calculate the size of theta to the nearest degree. Okay, so one thing you should note is that we have parallel lines here. So BD, let me just highlight the parallel lines. BD is parallel A whatever. And then whenever we have parallel lines and then we have a line separating them, that's where we have what we call alternating angles, which means this angle theta is really equal to that angle theta, to that angle there. So let's start there. Let's just start and say, okay, 7.1. Let's just say we are looking for theta. So let's say theta is equals to the angle A, B, D. Okay, angle A, B, D. So that angle there. And the reason is because of alternating angles. All right, and whenever you mention alternating angles, you must also mention the parallel lines, which is BD is parallel to A, the line of A, I don't know, whatever. So let's, because there's nothing there, let's just call it A. Okay, so that's the line we have to use. Now, if this is the angle we are solving here, look at here. We have a right-angled triangle. Okay? If you look right here, let me just rub this because we don't need it anymore. And then let me highlight what we do need. Let's use a different color. Let's say that. If you look at this triangle over here, A, D, B, A, that triangle, it's right angled right there. It's right angled. It's a right angled triangle, which means we can actually use Pythagoras. Okay, but since we're using we're solving an angle, we can use the simple rules. We can use SOHCAHTOA. All right, so what do we have? We have a hypotenuse. Okay, let me just write SOHCAHTOA first. SOHCAHTOA. Toa. Now what do we have here? This is our angle theta. So theta, we have 64, which is an adjacent. So we have an adjacent over, and then we have 81 there, which is a hypotenuse. Okay, so what do we know that's adjacent over hypotenuse there? It's a cos. So we know that cos theta is equals to adjacent over hypotenuse. All right, so let's fill that in. Cos theta is equals to adjacent is 64, and then the hypotenuse is 81. Then we need to solve for theta. So then we'll say theta is equals to cos, okay, arc cos, and then we put 64 over 81. We put it exactly like this in a calculator. Let's bring out our calculator. There we go. So it's shift cos, and then we have an 64 there, and then we have 81. Close this bracket. So it's 37.8. All right. Now they said calculate theta to the nearest degree. Nearest degree. So 8 is bigger than 5, which means 37 changes to 38 degrees. That's our final answer. Okay, now let's go to our second question. Now, our second question says, if it is given that BAC, all right, let me rub this. I want that BAC. Where is BAC? So BAC is like that. BAC. So we're talking about this angle here. Okay. Is that angle? It's 82.6. Calculate BC, the distance between the boats. So they want us to calculate this one here. All right, so we have a triangle there with an angle of, that's the angle of 82.6. Okay, now as you can see, this triangle is not right-angled rather. It's not a right-angled triangle, so we have to use another rule. Okay, so typically when you have two sides, okay, and we want to solve this side A, we have the opposite angle and we have two sides, we can use the cos rule. Okay, now we have to use the cos rule. Now 7.2, we're gonna say, remember the cos rule. Okay, this is an angle A, so it's A squared is equals to B squared plus C squared minus 2 BC, and then it's gonna be cos of A. Okay, but if we want A on its own, then we're gonna have to put everything else under a square root, just like this. Okay, 2BC and then cos A. All of this has to be under a square root because that was squared. Now we can start putting the actual numbers. What is represented by B? B, okay, so that's gonna be B. That's gonna be C because it's opposite. Now B is 87. So this is 87 squared plus C is 81. Okay, so that's gonna be 81 squared minus 2 times B, which is 87, times C, which is 81, and then times cos of the angle of A, which we've been given as 82.6. So that's 82.6. Okay, now all of this is under a square root. All right, let's bring out our calculator. Okay, so the first thing you do, open your square root and then put 87 squared plus 81 squared minus 2 times 87 times 81 times the cos of 82.6. What's that equal to? It's equals to 110.97. Let me just put it like that. Okay, that's it. Well, let's go to the final question now. Let's see what it says. It says, if now BDC is 110, where's BDC? I always like to highlight these things so that I know exactly which triangle I'm working with, because there are many triangles here in all honesty. So BDC, so BDC, that triangle there. Okay, so that angle is 110. Just write it. 110. Okay, and then let's say calculate the size of DCB. DCB. Okay, so that size of that. The triangle we're working with is a triangle at the bottom. Okay, so what do we have here? We have that angle is 110, and opposite that angle we just solved it. We just solved the side, 110.97. So it's it's 110.97 this side here. That's 64. So we can use the sine rule. Okay, which one are we gonna use? We're gonna use the one, it's gonna be easier if we use the one with the angles on top, because we're looking for an angle. If we're looking for a side, then we're gonna use the one with the side on top. So here we go. It's gonna be 7.3. So this one is gonna be sine, let's give it a name. So this one is D. So this side is D. That's C. That side is C. So we're gonna say sine C over C is equals to sine, what was it? D. Sine D over D. Now let's just go in and substitute these things. Do we know what sine? Do we know the angle of C? No, that's what we're looking for, the angle of C. Okay, do we know what C is? Side of C. It's 64. We have it right there. 64 is equals to sine. Do we have the angle of D? Yes, we do. We've been given it's 110. Okay, and then do we have the side D? Yes, we do. It's 110 as well, 0.97. Okay, so really sine C is equals to 64 times sine 110. All of this divided by 110.97. But if we wanted the angle of C, then C is gonna be equals to arc sine and then this whole thing, 64 sine 110 divided by 110.97. Okay, so let's put this in our calculator, see what we get. So shift sine, okay, and then we have a fraction, 64 sine 110, close the bracket, and then we go down. Under there we have 110.97. Okay, let's just go close that. Then our final answer is actually C is 32.81 degrees. That is our C. Okay, ladies and gentlemen, we are done with this question. We are done with the principles required to answer such questions. I hope you understood, but if in the event that you didn't, let me know. I'll be happy and glad to help you further. Thank you.